the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hello guys, welcome to another Smart BCAD video tutorial on the course Telecommunication Engineering 1. I hope you're having a great day. Today we are having a question on integral. We are asked to integrate the following signals. So we are having a impulse signal here with a unit step signal here. So solution. So let me quickly explain the basic principle of a impulse signal to you. So now let's say we are having an impulse signal. This asterisk is for the impulse signal and this is t. At this point we are having t. Here is 0 and here is 1. So for an impulse signal, it is only 1 at t equal to 0. So here is the signal. It is only 1 at t equal to 0. So elsewhere it is not valid. Therefore, the function unit impulse is 1 at t equal to 0 and it is 0 at t not equal to 0. So therefore this can also be expressed as, if you integrate this from minus infinity to infinity, if you integrate the tau by the t, you are going to get 1. So this is the basic principle that I want to explain to you, which is a what? A unit impulse signal. So now we are having a formula which says that if f of k is equal to integral of f of t from minus infinity to infinity, impulse which is shifted by a distance k dt. So here is the function. So our f of k now will be equal to, that is the total integral will be equal to this k, the function k which is being shifted, which the signal is being shifted to. So minus k will be equal to the value that you have here. So you are going to find the value of k. So let me quickly solve an example for you to understand this very clearly. So let's solve the first one, which is we are having a unit step with impulse. We are having a is equal to integral from minus infinity to infinity u of t tau unit impulse which is shifted by 2 dt. So now comparing this with this equation that we are having here, you can see that we are going to equate this to minus k. So now we are going to say minus 2 is equal to minus k. So therefore our k is equal to 2. So you can see now, so therefore our k is equal to 2. F of t, if you can look at this very carefully, because we say this is equal to this and this is equal to f of t. So our f of t here, our f of t is equal to u of t. So now if we should integrate this, so now we are going to have f of 2 is equal to u of 2, and this is the same thing as 1 because you are integrating only u of t. Now this is equal to 1. So now for the b part, we solve this like this because it is a unit step. So now we are having a function which is we are having integral t squared plus 3t minus 1. Then dt, our impulse is shifted. So here we are having integral minus infinity to infinity. We are having t squared plus 3t minus 1. Then we are having t plus 1 dt. We are going to say minus k is equal to minus 1 here. This point we are going to say is equal to plus 1. So our k is equal to minus 1. So here we are just going to have f of minus 1. So here our f of t, here is f of t. So f of t is equal to t squared plus 3t minus 1. So now we are going to be imputing this in this equation, since our f of k will be equal to, so instead of putting t is equal to k, we are going to be imputing k in this formula now. So we are going to have minus 1 squared plus 3 open bracket minus 1 minus 1. So 1 squared is 1 minus 3 minus 1. So our f of k, which is equal to f of minus 1, is equal to minus 3. And this is the same thing as the integral of the equation that we are having here. And it's the same thing as the integral of this minus infinity t squared plus 3. What we are having is the same thing. The integral is equal to f of k and is equal to minus 3. So this is our answer for the B part. So now the last but not least, which is the C part, we are asked to integrate integral of, we are having t cubed dt plus 4 dt. So now we are going to apply the same method. We know that our f of t will be equal to t cube. So, and here we are going to equate this place to minus k. Minus k is equal to plus 4. Therefore our k is equal to minus 4. So now our f of k is equal to f of minus 4. So now we are going to assume t to be equal to k. So now we are going to impute this here. So we are having open bracket, instead of t cube we are going to have minus 4 cube. So f of k now is equal to, so if you cube minus 4 we are having minus 64. So it's the same thing as integral of minus infinity to infinity t cube dt plus 4 dt is equal to minus 64. So I hope you enjoyed this tutorial. I hope you understand what I've just explained. I didn't do anything complex here. Here you are just asked to follow this formula. What you have to do first is equate minus k to what you are having in the impulse which is being shifted. So after that, equate k to be equal to t. So you find your f of t. Your f of t is the function that is being multiplied by your impulse. So you get it also. Then you finally find your f of k. Since you have your k to be equal to a value, you impute it and you finally get your answer. So I hope you understand this tutorial. If you have any question, please drop it on the comment section, or you have any recommendation, you can put it on the comment section. We'll meet in our next tutorial. Thank you.